Forest on a Hill is a small startup company looking to solve the world's biggest problems. Currently, we're trying to address the world's reliance on fossil fuel energy. This reliance on fossil fuel energy is unsustainable, and the need for a renewable energy source is ever growing. This need is the driving force behind a hydrogen economy, which presents a possibility for a pollution-free, high-energy density alternative. Forest on a Hill is working to make this economy a reality by producing hydrogen from food waste, specifically potato waste, which we'll be getting from potato processors. For this project, we'll be located in Houston, Texas. Due to the location of potato processors, as well as hydrogen consumers. Conventional methods for hydrogen production include gas reformation, water electrolysis, and coal gasification, which currently accounts for 96% of hydrogen production. There has been a push for biological methods for hydrogen production, which include microbial anaerobic fermentation, which rely on metabolism in order to produce hydrogen. Forest on a Hill is currently working to produce hydrogen using a cell-free, synthetic pathway biotransformation, also known as CBE, which is an emerging, high-efficiency process looking to produce hydrogen at a rate and a price which is competitive to conventional methods.
To produce hydrogen from potato waste, Forest on a Hill will utilize a combination of well-known and innovative technologies. First, the raw potato waste will pass through a filtration system where it is rinsed and undesirable solids are removed. The clean potato waste will then be liquefied into a slurry, and liquid chromatography or a density-based separation can be used to separate the valuable starches from the unusable lipids and proteins. These purified starches will then pass into the CBE reactor where they will be converted into hydrogen and carbon dioxide gas. These gases will then be separated using pressure swing adsorption and can then be stored and sold separately.
The true novelty of our process is the reaction mechanism. We will be utilizing a state-of-the-art method, CBE, which can achieve a high efficiency due to its ability to manipulate catalytic reactions under optimal conditions that cannot be replicated in biologically active systems. CBE works by utilizing a natural ingredient such as starch and converting it to usable hydrogen based on enzyme-catalyzed reactions. Our batch reactor will be filled with a slurry of our starting materials as well as a combination of 16 enzymes. These enzymes will participate in a cascade of reactions that will convert our starch into hydrogen and carbon dioxide. Through a simple stripping technique, the gases will be removed to be purified and stored.
Comparing the CBE process to traditional as well as current biological methods of hydrogen production, we have determined various critical success factors that will make our CBE process a competitive technology. Microbial anaerobic fermentation methods have led to a production of 9 moles of hydrogen per mole of glucose. With CBE, we estimate that 12 moles of hydrogen per mole of glucose can be achieved, increasing current production rates by 33%. Our CBE process will also be able to match hydrogen production rates of competing technologies, 100 million standard cubic feet per day, as well as a purity of 99.95 mole%.
CBE is a novel process for producing hydrogen, so we have the unique opportunity to explore this new process and make it as efficient as possible. We are initially going to be purchasing our enzymes for this process, while our top-tiered engineers are conducting research and development in order to synthesize the necessary enzymes. We are monitoring and minimizing our energy consumption from non-renewable sources in order to pursue a carbon-neutral process. Since we are producing hydrogen as well as carbon dioxide, we will need to be conscious of our environmental impacts by limiting, even capturing, our carbon emissions.
Process economics are critical for any successful business endeavor. Using company statements from other firms in the hydrogen production sector, we have been able to identify critical economic success factors that we must emulate to succeed in the market. We will be achieving these target benchmark values that other firms have set. Currently, hydrogen produced using biological methods must sell for $25 per kilogram in order to be profitable. In order to succeed in the market, we will target a sale price of $3 per kilogram, which is on par with the price of wind power produced hydrogen for sale in Texas today. Raw material cost minimization is of utmost importance, and as such we will be seeking to produce our own enzymes for the CBE process. To make these plans a reality, we will be securing loans from venture capitalists specializing in alternative energy.
Thanks for listening. We are Forest on a Hill. providing innovative solutions for tomorrow's problems today.